Good afternoon, everyone. I welcome you to another session of the Network Seminar Series hosted by the Center for Network Intelligence at the Robert Bosch Center for Cyber-Physical Systems, IISc. Today's talk is by Professor Manjunath, and he would be talking about revisiting net neutrality. Professor Manjunath obtained his BE from Mysore University, MS from IIT Madras, and PhD from Rensselaer PolytechnicInstitute in 1986, 1989, and 1993 respectively. He has been a faculty in the Department of Electrical Engineering at IIT Bombay since July 1998. He has previously worked at GE Corp.R&D in Schecectady, University of Delaware, University of Toronto, and IIT Kanpur. His research interests are in the general areas of communication networks and performance analysis. He is a co-author with Anurag and Joy Khoury of 2 textbooks, Communication Networking and Analytical Approach, and Wireless Networking, both of which are published by Morgan-Kaufman Publishers. Before we move on to the talk, we'd like to remind the audience to subscribe to our Google Groups for information on future talks. You can also visit our website for more details. I'll be pasting the links in the chat box. Please do check. Finally, I'd like to request the audience to keep your microphones on silent for the duration of the talk. Over to you, Professor Manjunath.
Yeah, so are the slides visible now? Just something else is showing on my screen. So
yes, we can see.
Okay, it's still visible on the screen. Okay, I'm going to go back to full screen and okay. Thank you for inviting me for this talk. This is so I'm going to talk about net neutrality. Okay, wait a minute, something is going on. Yeah, I'm going to talk about net neutrality. Some of the things that I'm going to talk about, it's actually a sort of a collection of results from a bunch of papers. But some of these some of the topics that I'm going to cover may have been, and some of you may have seen that before. And in many of these, I'm not going to go into the details of all the details, but sort of trying to give you a sense of the kind of results that we have obtained, and I mean the kind of questions that we asked about this, and the kind of conclusions we can draw, and sort of in some sense some kind of a policy guidelines wherever possible. Yeah, so the background to network neutrality, this was a very sort of a hot phrase a few years ago, but I mean I think different people came to this from different angles, and they have different sort of different ideas about what is net neutrality, where did it come from, and so on. I'm going to give you my view. I mean, this is not. I mean, this is the way I think about it. So the way. Okay, just to give you the background on how the internet was designed, developed, and deployed. So the basic principle of the design of internet was to keep the core simple and push as much of the intelligence as possible to the edges. And the outcome of this design principle was what is called the hourglass model. This is so popular in most of the textbooks, so I did not reproduce the picture. So essentially, it says that there are layers above IP, layers below IP, and all the layers, every application goes through IP. Okay, and you can have multiple access technologies on the layers below IP, like for example, Ethernet, Wi-Fi, cellular, and a whole lot of other stuff. And you can have different kinds of applications at the top and different kind of transport models, and each of them will be using IP. So if there are a wide kind of technologies that are going to be deployed below IP, and a wide range of applications that are going to be using the network above IP, so the IP had to be kept simple. And this simplicity was captured in something called the end-to-end principle, which is probably applicable in many places. Yeah, I mean, I can start rattling out a few other places where this is violated egregiously in many of our day-to-day activities. So the end-to-end principle essentially is this: that if a function needs to be provided at the endpoints, okay, for example, integrity of data, don't bother providing it inside the network. Okay, so for example, the biggest example they gave when this principle was enunciated was to say, look, if you are sending a packet and if you're sending a series of packets and they have to be checked for correctness and sort of aggregation at the edge of the network at the receiver, then don't bother trying to provide error correction on all the hops on the way from the source to the destination. Okay. So this essentially meant that it gave us a network of with a very small number of functions. And this kind of a principle, this comes from a different time when computational resources and memory was very expensive. So you had to keep as many things as little work inside the network as possible. So this was some kind of a necessity in those early days, and those sort of constraints are not there anymore. So that's just something to remember when we look at net neutrality. And so this design dogma essentially led to what I would call the laissez-faire network. And this laissez-faire network essentially led to a rich network applications ecosystem. Okay. And the upside, of course, I mean, the key output, the key outcome of this was that the network did not have to be aware of applications. Okay, so because the network did not care what you transported, and whatever application that you want to run on the network, the ends took care of whatever glitches that the network introduced. So the service and the content variety grew rapidly. So and inside the network, the resource allocation was egalitarian. This is an important one for net neutrality. Okay, so in the sense that they did not. The network did not care where the packet came from and where it was going or what it was about. So they just every packet was treated on equal merit. This was, again, I'll come back to that claim that it was because of a necessity. There was no the necessity was demanded by the kind of resources that was available at the time. And the way in which when things became cheaper and more available, and because of this background of not knowing or essentially egalitarian resource allocation, the resources were almost always being over provisioned. You know, the utilization of many parts of the network was significantly low. And Moore's law and bandwidth class did help help this design principle, because computational capability and storage capability was increasing rapidly. Bandwidths were becoming available in plenty, so you could continue with this principle. So very quickly, so although much of the bottleneck inside the network was sort of was reduced or did not really come up when the applications needed them, the bottlenecks emerged in the access. First in the DSL network. So some of the early what are famous non-neutral behavior by the ISPs came up in the DSL network. Okay, and now, of course, 5G and 6G might change things, but there is I mean, for many of the applications there is some kind of a bottleneck at the wireless access. Now, one of the key things that happened with respect to consumer users, both from the side of the content providers and the users, was that they expected the network to measure up. I mean, suddenly you're starting to download HD movies or 4K movies on Netflix, and Netflix will provide the content. It's not very hard for it to do, but the network has to be able to stream that kind of a content. That's the capability now sort of moved to the network, and both the content providers and the users assumed that the network could provide that kind of a resource. But the concept, of course, that providing that kind of a resource requires investment, and investment requires revenue for these companies. So ISPs became answerable to users, but they did not have the ability to monetize the kind of usage that was happening by the usage explosion that had happened content usage explosion that had happened. Now, so obviously when the expectation on the network exceeds the capability of the network, they'll start turning the screws on in some manner. And among the things that many ISPs started doing some, what people at that time called funny business. For example, they would close up P2P connections. they would not allow. So for example, the DSL was assumed with a significant amount of download bandwidth, download usage as opposed to and a very small amount of upload usage or uplink usage. So and when people started doing P2P networking, the uplink started getting used more and more, and that sort of through the made many of the dimensioning of the resources inside the network. It caused bottlenecks there. So they started, for example, in that case, they started closing P2P connections. That means from inside the network, when you're trying to open a peer-to-peer connection, the network would close it rather than the end user. So this was sort of something that the network was not supposed to do before. It has begun doing. Now, in addition, ISPs started exploring deals with content providers. Content providers are making all the money by passing through by using the resources of the ISP. I mean, naturally, there is an issue there, and ISPs were not used to being in that position for a long time. So ISPs explored deals with content providers to provide specialized services for their traffic, of course, which means that the content providers have to pay for that specialized fee. Okay, now. One view of exploring those arrangements with the CPs, content providers, I'm going to use the term CPs for content providers, was that, one view was that it is smart data pricing. You price the data according to the capability, according to the value of the users or the providers of that data. Now, in addition to this, the amount of intelligence that the network could sort of marshal for its functions, for its control, was significant. So, for example, deep packet inspection is a non-trivially compute-intensive activity. So, since they could do that, they could provide a lot more intelligence inside the network. Okay, when the ISP started looking into the packet and started sort of playing around or doing some kind of a management with it or treating different packets differently, secure network protocols emerged. HTTPS is an example, and those, because now the data is encrypted, deep packet inspection becomes harder or almost impossible. So there were content providers hit back there was a development on the content provider side to prevent this from happening. Okay, prevent the ISPs from doing what they were doing at the time. Okay, and then the activists got into the act. Okay, so again, I'm not going to expand on this. This is a recorded talk, so that's a separate conversation. And then there was a net neutrality movement. It is sort of a quick background to the story on this. Of course, this is my view, and there are variations on the theme that one can develop. So let me give you a little more background on the definitions and how different regulatory regimes view this. Okay, of course, the first principle came out of this a law professor from. He's now at New York University, I think. Okay, one of those New York universities. So his definition of net neutrality was, sort of his motivation for net neutrality. He was the one who coined the term, and it's a maximally useful public information network. This was the principle. Public information network aspires to treat all content, sites, and platforms equally. So this is sort of an economic/legal argument that he put forward, and he said, this should essentially lead to a neutral treatment of all traffic by the network. Okay, the European definition is that net neutrality means that all internet traffic should be treated equally, regardless of sender, recipient, equipment, application, service, or content. Okay, so now, what exactly does treatment mean has not been outlined here. Okay, so they are all considered. So, but typically it is understood to mean the QoS, the quality of service that different services or different packet, the origins of traffic or destinations of traffic should see. The QoS that the origins and the destinations see should not be different for different origins or different destinations. Okay, that's what it's assumed to mean. I'm going to expand on that a little bit later. Okay, the US had a slightly more expansive definition. So no unreasonable interference, disadvantage. Okay, that was sort of this thing. So the standard was there should be no unreasonable interference or disadvantage to specific groups or specific sources or destinations of traffic or specific traffic streams. Okay, requiring that the internet access provider shall not unreasonably interfere with or unreasonably disadvantage end users' ability to select access and and use broadband access service or the lawful intent, etc. I mean, all that. So the first part here talks about the users. Users should not feel disadvantaged or so discriminated. Okay, and the edge providers. So this essentially corresponds to the content providers. Edge providers' ability to make lawful content application services or devices available to end users. Okay, so this is sort of the US law. And a little bit more history on the US law. So what has happened is that the federal government some time ago said, okay, about 5 years ago, or maybe 5.5, 6 years ago, it was the US made a rule that internet should remain neutral, okay, according to this kind of a definition. Then about 3 years ago, I think that rule was scrapped and said no, there is no such thing. I mean, they used some similar anodyne terms to make to essentially dump net neutrality regulations, but many of the states picked it up. Okay, they said that we will want if ISPs are operating inside a state, they started to put in network net neutrality regulations. And then there were some court fights. I did not follow all the court fights between them. Okay, so there was something that was happening. So I guess that wheel has turned full circle and some version of this will come back there. In India, the story is very interesting. So the regulatory, there was a strong movement in India and a lot of awareness when Facebook tried to set up a service called Free Basics. Okay, or internet.org was the name of the service in other countries, or for a while it was that, and in India finally it was called Free Basics. Okay, and the idea here was that they would curate the content and they would partner with content providers and provide free internet to end users. Okay, only free internet only for the content that they have curated. So that was sort of something that many people were uncomfortable about. Okay. So that then in that time, the TRA, the regulatory authority in India, took up this notion, and they provided. They claimed that in the end, they claimed that we don't have to do anything specific, because the licensing agreement or the licensing contract that we give to the various licensees of internet service essentially say they have to give non-discriminatory service to all the users. So, there was some back and forth. For a while they said intranet traffic will not be subject to internet regulations and so on. But in the end, the latest document that I have available claims that, the license agreement as given is sufficient to enforce network neutrality. Okay, so the license agreement essentially has the phrase: the subscriber shall have unrestricted access to all the content available on the internet, except for such content which is restricted by license designated authority by law. Okay, so which means that the claim here was that we were legally a network neutral. We had a legally network neutral arrangement from day one. That was sort of the stand that the regulatory authority took. So that's sort of the background to network neutrality. So let me give you a sense of how non-neutral behavior happens in the network. Okay. By the way, if there are any questions, you can ask me anytime. Okay. So yeah. So some of these are stories, and a few models will follow. You can stop me and ask questions at any time.
Yeah. I think you have one question from.
Sure. Yeah. I can't see anything because I'm using full screen. So if somebody is moderating and stop me, I'll be happy.
Yeah, I have a question, Professor Manjunath.
Sure.
So our traffic classes in 802.11e, or now we are talking of URLLC, where we would give special treatment to some applications. Yeah. Are there also instances of non-net neutrality?
Yeah. So one of the things that I saw in one of the things that the regulations say is that they have identified a set of special services which are exempt from non-neutrality law. So if the service that you're talking about can come under that regulation, under that category of special services, then it can potentially be not under the ambit of neutrality. By the way, having said non-neutral, they allow for what are called okay, there is a phrase associated with it to say that the traffic management practices are allowed. So you can, for example, slow down everybody, okay, because something is happening, but you cannot slow down say, one class of users over another class of users. That's sort of the, the broad sort of the broad framework under which the law is being interpreted. I mean, there have been no test cases or anything like that, so there is virtually no way to test, test the boundaries on that. I mean, virtually to the best of my knowledge, there has been no court cases with respect to this. Okay. I don't know if that answers your question, but
yeah. Thank you.
Any others? Yeah. So there are two broad forms of.
Manjunath, I have a question. Rajesh here.
Oh, Rajesh, yeah. Hi.
Yeah. So you mentioned that the sort of simple core network was perhaps it could be considered as a happy accident necessitated by the need for simplicity, which enabled perhaps subsequent. It had possibly economic benefits of enabling several people to develop content, which was a benefit that was not foreseen at that time. But then subsequently, you went to definitions of neutrality. The reason activists perhaps might have come into this might have been because they saw the benefit of this simplicity and benefit of the content developers developing content and not having discriminated. So what is your take on that?
Yeah, I believe, okay. So the activists in India, I mean, at least when the time that I talked to a few of them, I don't think they knew the historical background. Okay, so I would agree with you that they saw the advantage and said, let's keep it like this. The only point I was trying to make was it was not designed. I mean, again, this is my view, and I'll go with the happy accident theory. That it was not designed to be this expansive. I mean, or at least, yeah, because, if you look at the early RFCs, many of them were, for example, look up things like RSVP and diffserve, intserve. All of these were attempts to provide, some kind of service discrimination inside the network. Reserve resources inside the network. There were attempts, but most of those things failed technologically because they were not technologically feasible, or at least they were not adopted technologically. I mean, ATM was another, so the acronym that was that somebody gave me about ATM was a technology mistake. Yeah. So ATM tried a lot of reservation inside the network, and virtually, I mean, it is now just a carrier again. Yeah. Again, this is my view, so and I'm happy to debate that and sort of, what shall I say, modify and modulate my views based on new insights.
Thank you.
Yeah. Yeah, so there are two broad forms of non-neutrality. One is QoS discrimination, so which is there are two typical manifestations of this. One is called paid prioritization. That means, for example, if Amazon Prime pays Geo networks, a certain extra amount of money, wherever there is a contention between, let's say, Netflix and sorry, what did I say? Amazon Prime. Yeah, whenever there is a contention between Netflix and Amazon Prime is given priority. That's sort of paid prioritization. Again, these are sort of very broad and crude classifications. I mean, there's a huge variety of these that can be designed. Another one is called fast lane. So essentially, reserve high bandwidth, some lanes for particular. I mean, high bandwidth. Divide the capacity into provide some capacity reservation for a particular class of resources. So this is sort of the two sort of broad models that can be done under QoS discrimination. So in each of these, the content provider is paying the ISP to provide either a paid prioritization or a fast lane for its traffic inside the ISP's network. Okay. So for example, before, for example, Amazon Prime's content comes onto the Bharti network or the Geo network, the Bharti or Geo do not have any control over what happens. But once it comes, it gets priority inside the Bharti network. That's sort of the view. The other is what is called price discrimination. Again, one can treat different content differently. Again, the price here is going to be paid by the content provider, and zero rating is a classic version of this. Zero rating here means that, for example, if you have a data plan in which you're allowed to consume, let us say, 100 megabytes a day, okay, some number. Now, and if you watch 5 movies on that, if Amazon Prime has 0 rated its content on your network, the bytes corresponding to the Amazon movies do not count against your data cap. That's sort of the interpretation, and Amazon is going to pay the ISP for 0 rating its content. That was sort of the other version. Again, as I said, there are multiple variations of this and a huge variety that can be, and these are sort of, this is one kind of an extreme. Okay. What is important here is that 0 rating has not been addressed in many Western countries, including the US. 0 rating is allowed. In India, both of these are legal. Okay, the 0 rating is okay. And just to come back to Rajesh's question, in India, the paid prioritization part never was an issue. I don't think nobody ever even argued that. The much of the activism in India came up because Facebook was trying to do free basics, and that was essentially some kind of a 0 rated service for a subset of the content of the internet, which was curated by Facebook. I mean, there were both moral issues and economic issues associated with that. Okay, at least as per the activists' opinions at that time. I mean, just so that, yeah, just to complete the story there, among the many activists that were there, at least one of the prime activists of that anti-free basics movement is now a Facebook employee. Okay, yeah. So what I'm going to do here is to talk a little bit about net neutrality. Okay, so the plan is roughly this. I'm going to talk about zero rating. Okay, what is the effect of 0 rating if it is?
Manjunath, Chandra here.
Yeah, hi Chandra.
Yeah, just a quick thing. In the slide, it says in India, neither of these is legal. But I think while you are saying, you said both of these are allowed in India.
Neither of these are legal. Oh no, I meant they are both are illegal.
Both are illegal. Okay,
both are illegal.
Both are illegal. Okay.
Both are not allowed by law.
Okay. Yeah, maybe I missed.
That's what I want to say. I don't know what I. Okay, I'm sorry if I.
Said Thank you. Thank you.
Neither of those are legal. Yeah, that's a negative, right? Yeah, it is a negative. Yeah, both are illegal. Okay, I mean, you know, I'm not sure if it is actually true in practice, in the sense that there are various ways in which 0 rating content is being provided. So I'm not very sure of that. We're sure of its in practice. As per TRAI's regulation, they are both illegal. That I know for sure. Okay. Yeah. So what I'm going to do is to talk a little bit about some effects of 0 rating. Okay, I'll first take a slightly simple model and then provide a slightly more complicated model. Okay, and then argue against non-neutral behavior by through at least this one. I mean, you know, there are of course other effects that we can. I mean, through other models of non-neutral behavior, one can also analyze and sort of come up with some policy recommendations based on that. That's one aspect. So I'll look at one simple model and an extension to that. So that's the effect of 0 rating model. And then I'm going to talk about a thought experiment. I mean, what in the case when 0 rating is, when any non-neutral behavior is not allowed, and if you look at the situation where ISPs need to invest money, but to improve the network, to enable the content providers to deliver content on a sophisticated network. I mean, if you claim that the ISPs cannot make money, okay, through smart pricing, and if they have to keep their network updated all the time, somebody has to pay the money. So if I'll do a thought experiment about what if the content providers decide to invest in the ISP. I mean, it's not too far removed from reality. I'll come back to that. So I'll take that thought experiment and then talk a little bit about how you can actually bypass net neutrality regulations. I'm not going to go into the details of that. I don't think I'll have that much time. So how one can bypass the network neutrality regimes and meaning stay legal and yet provide content in a non-neutral manner to the end user. So that's sort of the concluding remarks on that in this talk. Okay, so I'm going to look at this model. There are 3 players. So I'm going to look at the 0 rating. What exactly happens in a 0 rating scenario? So imagine the following situation. There is a group of users associated with an ISP. Okay, and there's an ISP which can set prices. Okay, sort of imagine the user base of Geo and Geo network which can set prices. And let's say two content providers. Okay, Netflix and Flipkart. Sorry, Flipkart and Amazon, or Netflix and Amazon, or something like that. Okay, so imagine that there are two CPs in some market, and there is a large user base. Let's assume that for every content consumed, CPI makes AI units of money. Okay, yeah, so AI is sort of the revenue or the good that is accrued on the content provider because of consumption, the rate at which revenue is accrued. And let's assume that the ISP is going to charge. So ISP now is in the middle. It is going to collect money from the content providers and from the users. You pay money as a subscriber to your network provider, and the content provider for connecting and transporting data over its network. The the content provider also pays the money. Okay, and yeah, so and it also gives the, let's assume that it gives the, so it charges P per unit on the user side and gives the option of sponsoring its content. So the content providers are now given the option. Okay, if they pay Q in addition to whatever they have to pay normally, if they pay extra Q, then the user will not be charged that content. Okay, so that is essentially what sponsorship is. So to sponsor its content on a user's on the network, the content provider has to pay the ISP Q units of money. Okay, and we'll assume that the users are utility maximizers. So okay, there is I'm not introducing all the notation, but I'll explain each of these terms slowly. Okay, so X is the amount of consumption that I'm going to make by consuming. X is the amount of consumption from content provider I. Okay, this is the consumption by the user mass, or the average consumption of a user. Either way is fine. Okay, so psi of X is the utility or the happiness that I get due to just plain consumption. Okay, now there are any number of potentially content providers. We are going to look at only two. So the script N corresponds to the two content providers that there are. Okay, now I can consume X1 from content provider 1 and X2 from content provider 2. So this should be in. Okay, so I am going to look at for all possible values of content consumption that I can make from the two content providers. I have a happiness here corresponding to this term. Okay, and of the two content providers that I have, some will be sponsoring. So those who are sponsoring will belong to the set S, and those who are N is the full set, and those who are not sponsoring is N minus S. Okay, so for those who are not sponsoring, I'm going to pay a P unit per price. So there's a cost associated with consumption, and there is a happiness associated with this consumption. Okay, so I'm going to adjust my consumption. The users are going to adjust their consumption such that this total utility is maximized. And we'll put a constraint on the user saying that it has some kind of a consumption capacity C. Okay, it cannot consume more than this capital C. Okay, now under this, if I know P, if the user knows P, if psi of X is known, and if the set of sponsors is known, this is a standard problem. You can figure out what this amount is. So under this utility maximization, let theta I be the consumption from content provider I. Okay, so I'm going to analyze this situation and by allowing the ISP to choose P and Q, I'm going to say that ISP is the leader in this game, and content providers sorry, there is some typo here, choose either S or N. Okay, that is they make the, I mean, they based on the pricing decision of the ISP, the content providers choose the decision. It's essentially a binary decision of choosing to sponsor or not to sponsor. Sponsoring corresponds to a state S, and N corresponds to not sponsoring. Okay, and based on the information about P, the price, and the decision of each of the content providers, P the price from the ISP, and the decision of each of the content providers, whether they are sponsoring or not sponsoring, the consumers consume to maximize this quantity. Okay, now what I'm going to treat this as ISP is a revenue maximizing entity. So it is going to choose P and Q such that its revenue is maximized. Okay, so that's the model. Any questions? Okay, so just to summarize, so ISPs will set the sponsorship price and usage charges. Sponsorship price is P and user charges is Q. Each CP then makes the sponsorship decision on an ISP. Okay, there's only one ISP, but later I have two ISPs, so I'm going to call it an ISP there. Okay, and a user joins. Sorry, this is the wrong picture here. Okay, so user just decides the consumption. Okay, so ignore this part because that is going to come back to the next model that I have. Okay, so there are two ways in which I can analyze this system. We can assume that P is exogenous, that is the price that one charges to the user could be exogenous and it doesn't have the ability to, the ISP does not have the ability to manipulate that. Okay, and the assumption to sort of the justification for that is sometimes the regulators demand that P cannot be much above something, or you can assume that there is some kind of an expectation or the amount of money that the consumers can pay is limited and so on. So for example, India is one of the, in India, the amount of money that the users can pay is supposed to be very, very small. The so-called ARPU is one of the lowest in the world. Okay, so this P can be exogenously determined, and let's assume that Q is the only thing that the ISP has control over, or we could also assume that both of these are can be manipulated by this thing. So in modeling, what we are going to assume is that A1 is some fixed state. So I'm going to parameterize my analysis by keeping the ratio of the earnings to some fixed level rho. Okay, so A1 is some A and A2 is rho times A. So I'm going to fix the rho and analyze what happens as A increases. That means the content providers sort of maintain a certain ratio of their monetizability of content, and they grow in that same ratio. Okay, so the assumption is that ISP will choose its prices to force the content provider sponsorship state. Now, mind you that there are two content providers, and both of them can either sponsor or not sponsor. So there are four possible states. Okay, both are sponsoring, that corresponds to SS. Only one of them is sponsoring, and then because A is larger than because A1 is larger than A2, we assume. I mean, we can actually show that if content provider 2 sponsors, one will also sponsor. So which means that the possible states of sponsorship are both of them sponsoring, content provider 1 sponsoring and 2 not sponsoring, or both of them not sponsoring. Okay, so P and Q will be chosen by the ISP whenever it is allowed to change that, to force the state that is the maximum, that gives it the maximum revenue. Okay, so corresponding to each state is a maximum P and Q that can be determined. Corresponding.
Manjunath, question.
Yeah.
Yeah, Aditya here.
Yeah. Hi.
So this once the ISP sets its policy, this CP is the CP assumed to be able to make its decision based on the user's utilities and anticipating what the users will do.
This is a full information system. Everything is known to everybody.
Okay.
Okay. So in the sense that the analysis is recursive. Does that answer?
Yeah.
Yeah. Okay. Yeah. So ISP will choose its prices to force the CP sponsorship into one of these 3 states. Okay. The one that is maximum. So another view to take here is that if I want to force both of them to sponsor, there is a maximum P and a maximum Q that I can use. Okay. Similarly, if I want the first one to sponsor and not the other one, then there's again a maximum P and a maximum Q that I can use. Similarly, the other two. So essentially, what you can do is what this ISP can do is to determine which of these 3 states. So look at each of the 3 states, find the maximum P and Q that it can get, and the corresponding consumption, and get the maximum revenue from that state. So that's sort of the way to think about this. Okay. Yeah. So I'm not going to go into the details, but give you the final result. So as a function of A, mind you that A is the A is the revenue per user, and there's a ratio in which these two revenues grow. Okay, so A is the revenue of the first content provider, and we are fixing rho. Okay, so the profit maximizing strategy for the ISP is the following. Okay, there exists a threshold AS. That means the revenue the revenue A has a threshold. Below this threshold, that means the content providers are not making a lot of money. ISP enforces a no sponsor equilibrium. Okay, by setting Q to be sorry, this should be less than A, right? Yeah, by setting a price such that this equilibrium is achieved. Okay. No, I think there is something wrong here. Okay, then if the profitability is higher than this AS, above that threshold, then it forces one of these three, whichever yields the maximum profit. Okay, so the idea here is that when the profitability of the content provider starts increasing, the ISP forces at least one of them to sponsor. Okay, so I don't know why this should be, there's some typo here. Yeah, the forces at least one of them to sponsor. That's sort of the bottom line. Okay, and what we will see later is that when that sponsorship is done, a significant amount of the profit that the content provider is making is actually taken over by the ISP. Okay. Yeah, so this is sort of some kind of an analysis for a particular sort of set of numerical examples. Okay, here remember that I'm allowed to choose only Q and P is fixed. So I have fixed P at some 0.05. Rho, the ratio in which the two profits are the ratio of the two profits is at 0.6. Okay, and the consumption capacity is some C. Okay, so what I have plotted here is as A becomes as A is increasing, what is the surplus and what is the state at which what is the state of the what is the state that is operational, and what is the profit that the three entities are making, and what is the surplus of the users. Okay, for two different quantities of C and P. Okay, it's two different combinations of C and P. Okay, as you can see, the Okay, so the user surplus as A increases is increasing. Okay, so first of all, these thresholds. Okay, in the beginning, for low values of A, it is both are sponsoring. Sorry, neither of them are sponsoring, and when A becomes large, both are sponsoring. Okay. Yeah. So you can see that as the profitability of this increases. So when the state changes when the state changes from NN to SN, the profit of one of them suddenly starts dipping. I mean, one of the content providers starts dipping, and see, mind you that this profit, if it had not sponsored, would have gone on like this, but it is paying increasingly larger amounts to the content to the ISP. That's basically the takeaway from here. Okay. Yeah, there are a few more analyses, but the essential result is that the ISP can take away a significant fraction of the surplus from the content provider when it starts making more money. Okay, but the user surplus is increasing, so one might think it is good for the consumers to allow sponsorship, but we will contend that the effect is that okay, we'll come to another the next model later in the next slide. I'll come back to that discussion later. Okay, so when ISP is allowed to choose both P and Q, the ISP's profit maximizing strategy as a function of A. Okay, the profit has the following structure. So there exist thresholds AS and AM. Okay, such that for A less than AS, sort of like before. So now I'm setting both P and Q. For A less than AS, there's something wrong with the Q here. I'll come back. Let's ignore that for a minute. Okay, for A less than AS, the NN equilibrium is forced. Between AS and AM, the ISP forces one of the two, SN or NS, and for A greater than AM, it forces only one of them to sponsor. Okay, so one of the ISPs is left out, and the other one starts fully sponsor. I mean, only it concentrated only on one of the two content providers. Okay, that's sort of yeah. Yeah, and what is interesting here is that Q is equal to A. Okay, so essentially, I mean, of course, these are results of the math model. Practice doesn't happen that way, but at least to get a sense of how much the ISP can squeeze out if this model is indeed true. Okay, so this is probably more illustrative. So what you can see here is that when it is allowed to set both the prices, the ISP profit just starts shooting up. The user surplus also reduces a little bit. But the content providers essentially are squeezed out completely. Okay, so if the ISP is allowed to choose on both sides, it can essentially squeeze both these people. So the immediate question is can it happen in practice? I'll give you one example from a long time ago. Of course, this was not quite the internet, but a similar situation before apps took over on the internet. There was a time when one could build services on SMS platforms. Okay, so text messaging platforms. Content providers, the host, but the caveat was you have to host it on the server of that particular service provider. And there was a time when the service providers like Bharti and others would demand about 70% of the revenue as part of the cut. Okay, a similar situation, for example, is there in. I mean, yeah, I don't think the analogy is complete, but one can see if there are analogies with iStore and Google Play and things like that. Okay, so let me quickly. I think I'm rather slow, so let me quickly jump to the. So I mean, the immediate criticism of that model is that there was only one ISP. What happens if there is ISP competition? If there are multiple ISPs, one can take the same idea, except now that you have to sort of model how the users get distributed between the two ISPs. So I can construct a similar model, two ISPs, two CPs. That's the only difference between the two. And the CPs now have to make multiple decisions. They have to decide whether they want to sponsor on content provider, on ISP1, and whether they have to sponsor on ISP2. So they essentially have two separate decisions to make. Okay. And what we will assume, and users also have a choice of whether they want to go to ISP1 or ISP2. Okay, so the way we model this is that we'll assume that the users are sort of located uniformly on a straight line, with one end being ISP1 and the other end being ISP2, and they have a certain amount of affinity. So essentially, the kind of the cost of joining a particular ISP depends on its distance on the distance of this particular user from that ISP. Okay, so M here is a sponsorship configuration. That means M1 is a sponsorship configuration of CP1. M2 is a sponsorship configuration of CP2. No. M1 is a sponsorship configuration on ISP1. M2 is a sponsorship configuration on ISP2. So if both this decision is made, the users calculate a utility, okay, of obtaining. So UM1 is the utility they get by joining ISP1, plus there is a cost of switching to the other side, and similarly so you can use this kind of a structure to differentiate, to decide whether a user at point X on that line, going from X takes values from 0 to 1, decide to go to ISP1 or ISP2. Okay. So T is some model parameter which assigns the cost of moving, the cost of switching, basically. Okay, so in this analysis, I mean, because we already have too many variables, we'll assume P is exogenous and the ISPs can only decide Q. Now, I'm going to assume that, okay, the way we want to analyze, the way we will analyze this, we'll assume that the sponsorship configuration on one of them is fixed, and we will see what the other side does. I mean, for example, we can fix M2. Neither of them are sponsoring on M2. They exist. So this is sort of like the public option. For example, there is BSNL. If there is BSNL, what would Bharti or Jio do if it is the only other competitor to BSNL? Okay, so we can assume that, I mean, just like before, we assume A1, A2 is A and row A. Okay, and we fix the row, and we have a similar behavior. So there is a threshold AS below which ISP1 forces an equilibrium. Mind you that the other side sponsorship is fixed. ISP1 forces an NN equilibrium, and for A greater than AS, ISP1 forces an SN-SS equilibrium. Okay, and yeah, so for A greater than AS, there exists a ratio. So if you fix the A's, okay, if you fix the A, there exists a ratio such that for row less than row S, that means there's a threshold of the ratio of the size of the two CPs, the ISP1 will force an SN equilibrium, otherwise it forces an SS behavior. It sort of forces the, I mean, essentially, even with two, even if one of them is, even when there are two competing ISPs, and one of them is not allowing sponsorship, the other fellow can extract surplus out of it. I mean, if the profitability is high. Now, I can look for many other sort of potential situations here. So I'll just, I will probably just say this one and skip the others. Okay. So under any symmetric equilibrium of the form QM, so Q here corresponds to both the ISPs choosing the same sponsorship configuration and choosing the same sponsorship price. Okay, then okay, and if the equilibrium that we choose is SN or NS, that means only one of them is sponsoring, then the CP that sponsors on both the ISPs makes the same profit as it would if zero rating were not permitted. This is sort of a very critical result. So, you know, sponsoring here, if the two ISPs sort of collude and force us collude, or it so happens that there is the sponsorship is the same on both and the prices are the same on both, then the CP can actually be not making any extra profit in the presence of zero rating. Of course, there's the administrative cost of managing that zero rating. Okay. And in this case, the CP that does not sponsor will make less profit than if zero rating were provided. So if you're looking for if symmetric equilibrium were possible, sorry, under a symmetric equilibrium, the CPs are going to lose out. Okay. Yeah, and if both of them are sponsoring on both of them, then at least one of the two will make a loss. Okay, so there are several other such results which essentially points to the fact that the effect of having competing ISPs is not going to change the picture significantly. The ISPs can squeeze out the content providers. There is the potential argument that the users benefit because they pay less. But the disadvantage, the issue with that argument is that if you take out the CPs, then the CPs become the CP space become. I mean, if one of the CPs start losing money, then that CP goes out of business, and there is a long-term effect which is not part of the model here. Okay. So this is sort of some pictures about what will happen if under different models. Essentially, this is the value of A1. The x-axis here is the value of A1. Y-axis is the value of A2, the revenue that the two CPs make, and we are looking at what kind of configurations will happen. I mean, whether both of them will sponsor, one of them will sponsor, and so on. And you can see when it becomes more profitable, both of them will have to sponsor on both of them, I mean, and on both the ISPs. One can also analyze the revenue and see that the ISP starts making significantly more money out of it. I'll skip that picture. Now, a quick question here. Again, I think I have too many slides here. I'll probably just go to the punchline here. Now, this is a thought experiment. Okay, here what I'm asking for is the CPs will now. I'm asking the CPs to invest in the ISP because ISP is going to because investing in the ISPs helps the content provider because their content is going to get delivered better. Okay, so there is some kind of an incentive for the CP to invest in the ISP. The issue though is that there will be free riders. Okay, so if Google, for example, invests in an infrastructure, there could be other smaller content providers who can extract some benefits out of this content provider, okay, out of this improved infrastructure. So the question to ask is in that scenario, is there a scheme where we can think of the content providers to see whether the content providers have any incentive to invest in the infrastructure? Okay. So I mean, as I said, this was a thought experiment. I don't think this is too close to reality yet. But if you still want to think about it, some of the the network service that Google is providing can potentially be viewed as some version of this. Okay, now we can assume that CPs act as a single entity seeking to maximize the network surplus. Mind you that there's an investment cost, that investment they make in improving in the ISP's infrastructure. Okay, corresponding to that improved infrastructure, they get some better quality of service for their users. And because of the increased quality of service, the users will use their content more. That's sort of the feedback loop that we are assuming. Okay, so we can assume a cooperative situation, and we can analyze the amount of investment they make. Mu is the investment that they make. Nu is the profit that they make per unit traffic, and Xi is the amount of increased bandwidth, that the increased usage that a content provider gets if there is a total investment of mu. Okay, so one can, if you treat the total mu as some kind of a cooperative scheme, then you can essentially quickly solve this problem and obtain some the way in which how much of money is going to get invested. Okay, but what is interesting is, what if they are, okay, I think this picture is not very good. So the question to ask is, what will happen if the selfish if there is no cooperation between the content providers, and what kind of investment will they make? Okay, so that's sort of, so yeah, so this is sort of the investment. QI is the action of CPI, and we want to see if there are n separate content providers. Okay, how much of investment will each of these make? So I'll skip the so there is a possible, the tragedy of commons in free riding is the issue. Okay, I'll give you the final decision on this. So you can actually compute the Nash equilibrium. We can show that. So we are looking for a non-cooperative setup, and we can show that there is a Nash equilibrium associated with this, and we can characterize the Nash equilibrium. But what is interesting is that you can treat this as, and you can calculate the price of anarchy. I mean, you have the cooperative setup, and you can look at what happens in the non-cooperative setup, and you can do this characterization, and you can show that the price of anarchy is always strictly greater than 1 in this case. Now, the interesting thing is what happens, I mean, instead of a non-cooperative setup like that, what if you bargain? Okay, so a practical implementation of bargain is to sort of announce who is doing what, sort of like, like institutions announcing their donors. This person gave that much, that person gave this much. So there may be potentially some kind of a competitive, let's say, donations, and what kind of benefits can you get? And mind you that there's a benefit that both accrue. I mean, probably, yeah, there are several scenarios one can envisage here. So yeah. Yeah, so again, I think I have to introduce a lot of notation here. So I'm going to skip the details here. Essentially, what I want to tell you here is that if there is a bargaining is allowed, the total investment in the ISP by the investors, the total investment can exceed the cooperative setup. Okay, so CPs can actually, there is a potential for the CPs to actually invest more under a bargaining framework than under a cooperative framework. That was sort of a non-intuitive result. But if you look at the math, it is sort of fairly obvious. So there are essentially two potential equilibria. One of them is above and one of them is below, and so on. So you can figure that out. So we define this quantity called the benefit of bargaining, and we can show that it is strictly greater than 1. Okay. So the summary here is that, yeah, so if I'll skip some of these details. So the basic idea here is to, because the content providers are making a significantly more amount of money than the ISPs. So is there some way that we can transfer the surplus that the CPs are making to the ISPs? And we presented some mechanisms for doing that in keeping the network neutral. Okay. Now, so just to conclude, I want to sort of look at a completely different scenario, what I'll call the net neutrality bypass. Okay. So although there is a legal requirement that the ISP be neutral, okay, the neutrality is only with respect to neutrality of the traffic is only after the traffic enters the ISP's network. Okay, so now is there a way to sort of look at that and see what can be done, or how non-neutral service can be provided? I mean, it is from some large content providers' view. So a simple thing to do is to have a peering between the CP and the ISP. What this means is that the content provider will place its servers deep inside the ISP's network. Okay, so instead of taking the scenic route to come from a server in California, the Netflix traffic is actually sitting right here in Mumbai or in Bangalore, and it will take far fewer hops to reach from its server to your home, okay, or to your edge device. That is sort of something that is happening. Okay, so you can ISP and content, this ISP and CP peering, it can bypass the transit network, and I'll come to another important point. Okay, but this cannot be done at a large scale, meaning that a Google can negotiate with a Bharti, okay, or Netflix can negotiate with somebody, but if there are many small content providers, that negotiation is not possible. So this pairwise bargaining between and there are, of course, not just Netflix, but a whole bunch of other content providers. Okay, so how do you, I mean, what happens? I mean, how do you bridge that gap? Okay, so this is the economic gap to allow for pairwise bargaining between the ISPs and the CPs. Okay, and mind you that another complication with this is that the ISPs and CPs are not always symmetrical. Sometimes in some markets, the ISPs may be more powerful, in some the content provider may be more powerful, or in some, it depends on the pairing. And there are large transaction costs. I mean, if somebody has to sit and negotiate this, there are significant transaction costs. So an important development since about mid 1990s to overcome this engineering gap, so this economic gap, and which also overcomes the engineering gap. The engineering gap here is that much of the content does not want to take the scenic route from California to your to your device. It wants to come from a closer node, and so what was called the best effort service is not enough anymore. You want better than best effort service. Okay, so a device that has that has sort of is gaining increasing importance in that are content distribution networks. Okay, CDNs, Akamai and Lightstream and those kind of organizations. So they what I call the engineering gap, they bridge what I call the engineering gap and the economic gap. The economic gap because they bypass the need for a content provider and an ISP to sort of negotiate every potential pair of these to negotiate and peer. Okay, so they essentially aggregate. So they provide they will connect. They provide a mechanism for these two to come together in some place, some kind of a platform. If you're familiar with model, I mean, this is a two-sided platforms kind of economic models. So the CDNs are aggregating traffic from multiple CPs, especially the small and medium CPs, and connect directly to the ISP. Okay, now what is happening is that I'll give you two examples of how this is actually happening in practice. So in Netflix, there is something called, this is a content provider directly connecting to an ISP. They have a scheme called Open Connect, okay, where a content provider, which is not large but is small, can directly connect to that. They claim there is no fee, but I'm not sure of that. Okay, there is no published information about what it costs and so on. Okay, there may be hidden costs which we don't know about. That's the point I'm making. So Open Connect of Netflix is essentially a mechanism of a CP to ISP peering. Okay, and a similar mechanism from Akamai is called Accelerated Network Partner. Okay, so this is how smaller ISPs connect to CDNs. Of course, the larger ISPs, there will be negotiations between them. Okay, so what is the economic effect on the CP marketplace of the existence of the CDN? What you can see now is that CDN is sort of like a platform which is providing a needed service for both sides, that is ISPs and CPs. So it has a role very similar to the ISPs in the previous case, except that ISPs was bridging in the previous models. The ISPs was bridging the connection between content providers and users. Here, the CDN is bridging the gap between an ISP and a CP. Okay, so the ISP part is sort of, I mean, ISP to user connection is sort of assumed. Okay, so it is some kind of a business to business platform. Okay, which you can now analyze as a two-sided market. Okay, or a two-sided platform. Now, what is interesting here, and everything that every non-neutral behavior that you wanted can be done through a CDN. Okay? You can provide trade prioritization, you can provide fast lanes. You know, because the hop between the server, the CDN server and the user is very small. Okay, so the effect of that is sort of smaller, is not significant. Everything else is now sort of handled by. I mean, you are neutral on the last hop, but the last hop hopefully won't matter too much. Okay? If that is indeed the case, then CDNs essentially now become the arbiters or the gateways between a content provider and the ISP. And what is very interesting is that the net neutrality regulations of TRII explicitly mentions that CDNs are not under the ambit. No other regulator that I know actually does this. Okay, so TRII has explicitly omitted CDNs from its ambit. Okay. So essentially, you know, my contention now is that CDNs can become conduit to make the network non-neutral. Okay, so given that this is the emerging situation, so we have seen how, I mean, one example of how if non-neutrality is allowed, a particular player can benefit significantly. Okay, and that model can be extended to other scenarios. Okay, we have a thought experiment of allowing for investment in the ISPs by people who are making a lot of organizations that are making a lot of money. Okay, to potentially sort of overcome the issues associated with neutrality. Okay, and then if net neutrality is indeed an important principle, there is being non-neutral indeed gives you advantages to either the ISP or the CP. Here is a vehicle to achieve that. Okay. So given that this is and there is no reason to believe that this is not happening, because there's no way to measure this also. So the question is there net neutrality on the internet? So I'll leave you with that question and answer any other questions that you might have. I skipped a couple of results because I was sort of running short of time, but I guess I overshot still. Sorry about that. Thank you very much for your patience, and I'll be happy to answer questions.
Thank you, Professor Manjunath, for the wonderful talk. Since we're already past time, maybe we can take at most one question.
No questions. Okay.
Okay, if there are no questions, then I think we can conclude. Thank you, Professor Manjunath, again.
Thank you.
We'd also like to remind our audience to subscribe to our Google group, which is the mailing list for information on future talks. And you can also visit our website for more details. The links have been posted in the chat box. And the link to the recorded video will be posted on the webpage. Thank you and have a great evening.
Thank you.
Thank you.